For those of y'all at home, if you have your bonding packet, get it out and pause the video for the screen. All right. Yesterday, we were introduced to reactions. We know that reactants yield products, and when I say yield, it's a little arrow that separates the reactants from the products. We know that if we're given an English sentence, that every word and sometimes phrase tells us to write down something. All right, symbols, pluses, yield signs. We also know that after we have everything written down, it's important to make sure that all of our compounds follow nomenclature rules and that all of our free elements have little 2's dropped if they're part of Brinkelhoff. That's all yesterday. Now, I referenced yesterday, though, that we weren't quite doing everything we needed to do because all of your examples, I think all of them, were unbalanced, meaning that when we were done, and you compared maybe the number of aluminums as a reactant to the number of aluminums as products, they were existing in different amounts. And that's impossible, all right? In the lab, when you have your reactants and you mix them together, they do things, right? And they make new stuff, but that new stuff is composed of the old stuff, just rearranged. You can't gain or lose stuff. So when you translate yesterday's skill, and then you look at what you translated and you're like, the numbers are off, you've got to fix the numbers. This is called balancing. This is a cornerstone chemistry concept. A lot of times when people when you're 40 and you think about chemistry, someone brings up, you're like, I took chemistry, I had the best teacher ever, blah, blah, blah. No. Oh, I'm still recording, all right. Sorry, my screen shut off and I don't know how to turn it back on while we're recording. So you get to watch me figure this out. I'm going to finish that thought, though. When you think back to chemistry many, many years from now, usually balancing reactions is one of the first things that comes to your